All right, good afternoon. Let's go ahead and get started here. Like I mentioned in class on Monday, the introductory assignment is due tomorrow, so please upload your response for that by 12 o'clock to MU Online. And don't email it, don't print it out, it's just strictly electronic submission through MU Online this semester. Now if you look at the course schedule that I gave you on our first day, you'll also notice that homework assignment 2 is due on Wednesday the 23rd. And that homework assignment is also posted on MU Online. You can find the PDF of it there. There are a couple of questions that you could already have started working on based on what we covered in class on Monday, and we're going to cover some more of the topics in class today. So I encourage you to get an early start. It's a really good habit to take a quick look at the homework assignments early on rather than the less effective approach of leaving it to the night before. And that way, if you get some early exposure to it, then as you're receiving the material, you may recognize some of the things you have to do in the homework with what you're hearing in the lecture and what we're solving in the in-class exercises. And then that also gives you the chance to ask me questions if you face any uncertainties. So get an early start on homework 2 is my suggestion. Okay, how many of you, by a raise of hands, have ordered the textbook? Okay, good, very good. Maybe some of you already had it. How about printing out the notes? Were you able to find the notes online? Okay, I see nodding heads there. One last thing, what about a binder? Because like I mentioned before, we're going to have 43 in-class exercises through the course of the semester, and you've already got access to the lecture notes, and so that's a lot of loose leaf papers that would be best off in a 3-ring binder. So that's another suggestion, that if you haven't already got a binder for this class, I'd suggest that you put one together just so you can keep everything in one place and it makes it easier to study as the exams approach. Okay, today we're going to continue talking about interest rates. And before we get into that, are there any questions on the announcements or just anything in general? Yes? Good question. Yeah, those are the full notes for the entire semester. Now I may occasionally make some adjustments in excuse me, a slide here or there. I sometimes change the ordering around a little bit. And in fact, that's the case today. I made 1 or 2 adjustments to the notes for today's lecture, but what those notes are is those are the lecture notes at the end of the last time I taught the course in the fall semester, and so I put them all together now so that you can have access to them early on. Okay, well let me ask you a question. What's the difference between interest rate and rate of return? Okay. Okay, very good. So just like he said, the chief difference between the two is perspective. It's whether you are the borrower or the person who's loaning the money. And the formula is the same for calculating the interest amount. The formula is the same to calculate that as a percentage. It's just a matter of perspective. And a lot of what we're going to be covering today actually addresses the idea of perspective as well. So we're going to start off with the in-class exercise, and then I'll actually do a brief lecture after we get into the in-class exercise. And so let me hand those out. For today's in-class exercise, we're going to start by looking at a table of interest rates, and I'd like you to speculate a little bit. I'm going to ask you to consider, for the interest rates that are shown up on the screen, and I'm also handing out the paper now, why is it that maybe one rate is higher than another? Why is it that certain interest rates seem to be extremely high? Maybe some of you have already borrowed money, like student loans, or maybe some of you have credit cards and have felt the bite of credit card interest. But for this one, questions A through E, I'd like you to go ahead and collaborate with your classmates, come up with some critical thinking, short answers to each of these questions. Now, I have to warn you that this semester you're going to do a lot of calculations. It's an engineering course after all. But at the same time, a really important part of this course is being able to explain and understand the reason why. And the reason why I feel that's important is that you're going to be more than just a technician. You're not going to just be plugging numbers into formulas that you're given and calculate away. You're not a calculator operator, but engineers have to understand the fundamentals. And one of the best ways to learn the fundamentals and to assess them is through explaining concepts. And so short answers like this will be on almost every quiz. They'll be on every exam. So it's important for you to take the ability to answer questions seriously. And so don't just give one-word answers is what I'm getting after here. Really try and be as thoughtful and detailed and at the same time concise as you possibly can. So I'm going to pause the recording, give you some time to work individually on this. Do you have a question? Oh, you guys need a few? All right. Are there extras on this side? Yeah, I don't count them out before I put them down each row, but we've always got plenty. Thank you. All right. So go ahead and discuss amongst yourselves. Please put a good response on the paper, and then we will revisit the answers together. All right. Let's talk about this table. Now, first of all, remember in the first lecture on Monday, we talked about how one of the reasons why interest is charged is to account for the time value of money. And you're going to hear that phrase, time value of money, a lot of times this semester. Can anyone briefly just remind us what time value of money is all about? Yeah.
Money that you borrowed today is worth more. You can buy more with it, whereas money in the future, because things increase in price, you might not be able to buy the same amount of things with the same amount of cash. So interest is used to account for that.
Exactly right. Very good. That's an excellent explanation. So what he said is the money that a certain number of dollars today, whether it's 100 or 1,000, a certain number of dollars today can buy more stuff than it will be able to buy in the future because prices are going up over time. And so if you're taking money from someone today, those dollars that you're taking are more valuable than the dollars you're paying them back with. And so naturally they're going to want more of them if each individual dollar isn't worth as much. So that's part of what's going on with interest. Now, on question A, it asks, why is the savings account rate the lowest? And we'll start off by, these are all products, as they're called, by a bank. But one of these products is different from all the rest, and it's the savings account. How is the savings account product different from all of the others?
We're making money opposed to them making money.
Exactly right. And so it's different from all the rest because in the case of a savings account, you, the individual, are giving money to the bank. And so you're the investor and the bank is the borrower. And so in the case that the bank is the one who is going to be paying you, what do you notice about those interest rates? It's the lowest. And so naturally they don't want to pay you more than they're going to be earning on the loans that they give out to other people. Because essentially what they're doing is they're taking the deposits from their depositors and they're using those deposits in the loans that they make to other people. And so how do they make their profits? It's the difference between the two. They borrow the money from you for very little, and they take those same dollars and they loan them out to someone else for a little bit more, and they keep the difference. And so the first thing we see in question A, what I said, why is the savings account rate the lowest? The way that I put it is because with the savings account, the bank is paying the interest. So it's a matter of perspective. In that case, they're the borrower, and when they get to call the shots by saying what the interest rate is, they'll have that be pretty low. It's really hard to get ahead today if you're the one who's loaning money to banks. Savings account rates are kind of lower than they've been in a long time. Okay, question B. Have you ever heard of a CD before? Does anybody know what that abbreviation CD stands for? Certificate of deposit, that's right. And so what is a certificate of deposit?
Basically how I understand it is it's a deposit you give into the bank and you keep it there and it accrues interest.
Uh-huh.
And you can take it out whenever you want, but
said that's a secured lending.
Okay. I think you're right. Certificate of deposit is a fixed term deposit. And so the person who's putting the money in actually can't take the money out anytime. I mean, you can, but then you have to pay a penalty. And so it's different from a savings account, because a savings account, the depositor can take the money out at any time with no penalty. In a certificate of deposit, what's not listed here is often a bank will have a 1-year CD, a 2-year CD. And so at the beginning, when you're first putting the money in, you tell them how long you plan to leave it there. And it's advantageous to the bank because then it gives them a little bit more flexibility in how they use it. You know, they can take CD money and make a longer term loan with it because they know that it's not going to be, someone's not going to come in asking for their money back right away. So because of the additional flexibility it gives to the bank, they pay slightly higher interest rates than for a savings account. So that's the essence of question B. Now C, I'm interested to know, what are your thoughts on why might the mortgage rate be higher for a 30-year loan compared to a 15-year loan? Why is it that a bank wants you to pay 4.29% for a 30-year mortgage loan, but would only charge you 3.50% for a 15-year mortgage loan? Why do they demand more for the longer term? Okay. Change in value of money. All right, well, let me play the devil's advocate here. But they're already getting interest the same, you know, like they could have just charged 3.5% over 30 years. Why does it have to be more for the 30-year term than it was for the 15-year term? Because they're already getting some money back. Okay. That's a good question. What's?
Make more money off of you?
Oh, they always want to make more money. You're absolutely right. Yeah.
It's a greater liability for them to get a few for 30 years and 15.
Why?
Because whenever they don't have that money for half as much time, they don't have as much they can get out and make from.
Okay.
It's more liability for them to give you a 30-year loan that you may not pay all.
You're saying that they're making a long-term commitment. Yeah, sometimes you want more when you're making a long-term commitment.
Someone could suddenly lose their job 20 years down the road. In 15, they'll be fine because they've already paid it off. In 30, that's 10 years of not having their career.
Okay. What was your idea?
I think if the same amount of money distributed between 15 and 30, you pay less for 30 years?
Yeah, each monthly payment is lower. Yeah.
And because of that, the money you pay actually is like, you pay the exact same money at the future, so you have like less worth of that.
I see. Those are all really good ideas. I think that we could distill all of them, consolidate them into one word, and that is risk. When a bank makes a loan, they're taking on some risk because they just gave you a big pile of money and they've got their fingers crossed that that's going to come back to them. And so a 30-year mortgage is more risky to a bank than a 15-year mortgage. And there's a variety of reasons why it's more risky. It may be that employment is less guaranteed over the long term, you know, because in 30 years the robots are going to have us all out of a job, right? But, you know, another big factor of it is think about time value of money. How much is a dollar going to be worth in 15 years? That's not scheduled. I mean, we don't know in advance. Predicting the future is very uncertain. We can look into the past and we know what inflation was over the past 15 years or the past 30 years, but we don't know what it's going to be in the future. And in the future, there's more risk for the bank over a 30-year time frame in terms of how much inflation there might be. And here's a really bad thing for the bank. It's bad if they're only charging you 3.50%, but then inflation goes up to 4%. So that means if money is losing its value more quickly than they're getting interest back, then what that means is that the purchasing power of their dollars is actually decreasing. And I know there's some new terms there, and it's a complicated idea, but just think of it this way. What if you were making a loan to a friend, and you said, all right, I'll give you $1,000, and you have to pay me back $1,100 in 1 year. But suddenly the economy went crazy, and now it costs $2,000 to buy a loaf of bread. I mean, you've heard about countries where that happens, right? Zimbabwe, I think it's happening right now in Venezuela, hyperinflation, where you have to take a wheelbarrow full of money to the grocery store, that kind of a thing. Well, when there's lots of inflation, then the money doesn't really buy as much as it used to. And so if you have just loaned out a bunch of money and the people can pay you back with worthless wheelbarrows full of money, then you're in big trouble. And so risk, the main thing I said we could boil it down to risk. There's more risk for the bank with a longer term loan because there's a possibility that the value of money could erode faster than they are recovering it back from the borrower. So we'll come back to these ideas again. These concepts are complicated, but I did want to point out that the one word that can explain it is risk. And let me see how I answered this part C. In 30 years, there's a higher risk that the interest rates could go up above the rate charged by the bank. Yes?
Would it also be correct to say that like the mean credit value of borrowers that are attracted to a 30-year loan would be probably significantly lower than those that could get approved for a 15-year loan and meet the requirements of a 15-year loan?
That's a good point. Yeah. Yeah, so your point is that if someone's borrowing for a 15-year term, the payments are higher, so maybe they have higher income, they have a better credit history. That could be. I think people with poor credit would probably face even worse interest rates than these. You know, within each loan type, I think there's probably different rates for different credit worthiness, but there could be something to that as well. Okay, so think about risk. Why are auto loan rates higher than mortgage loan rates? Yeah.
A car loses value much quicker, so it has to be repossessed, whereas like houses gain equity over time.
Exactly right. She hit the nail on the head. So cars lose value over time. We call that depreciation, whereas homes increase in value. And what are those things called? Like the house or the car, as far as the loan, what is it? An asset. When it's securing a loan, we call it collateral. So an asset that secures a loan is collateral. And so if your collateral can be driven around, and if the collateral can be in an accident, or if someone can hide the collateral when you're trying to repossess it, then that's more risk, right? If the thing loses value inherently, then it's more risky, and so that's the primary reason. Now there's lots of other little reasons as well. You know, the term is shorter, so the bank wants to get more of their profits right up front. That may be also a minor factor, but it all boils down to risk. And the same thing comes into play with the credit card. What's the situation with the credit card? There's no collateral. Yeah, think about what type of purchases people make with the credit card. You buy your lunch with the collateral. With the credit card. And so, you know, like the collateral that a bank is going to repossess, you've already digested. Or a trip to Mexico, or a television. I mean, I guess they could send someone to take the television off your wall, but that doesn't happen really often. And so it's more difficult for a bank to repossess the collateral in the case of a credit card. And actually, the way that it's put is that a credit card is an unsecured loan. You know, they can sue you and take you to court, and they maybe are able to garnish your wages, but there's no single item that you pledge to give back to them if you don't pay the loan in the case of a credit card. And so the interest rates are astronomically high. Also because of the convenience of it. So you have to be really careful with credit cards. Any questions about the front page of that in-class exercise? Okay, so let's talk about different account types. A checking account is sometimes also called a current account, and those are used for frequent withdrawals. I was at the grocery store last week and I saw someone write a check, and that took me back. You don't see checks as much as you used to, but now people usually access their checking account with credit cards rather than, with debit cards rather than checks. Typically you get very little, if any, interest on a checking account, but savings accounts are intended for fewer transactions per month, and a lot of banks have rules that you can only have 5 or 7 transactions a month in and out of a savings account to try and limit the turnover. And you do earn interest, but not very much. A money market account is a hybrid between a checking and a savings account. It's interest-bearing, but oftentimes money market accounts can have checks associated with them. The funds can be withdrawn at any time. And usually the balance requirements are higher than a typical checking account would be. And so money market accounts are sometimes associated with investment accounts, like if you have stocks, then the uninvested funds may be in a money market account that checks can be written against. We already talked about a certificate of deposit. Debit cards and credit cards are both plastic, but how they operate is different in some ways. When you spend money off of a debit card, you're spending your money. And if it gets lost and someone uses your debit card, the person is spending your money. Now, you can usually get that money back if it's an unauthorized purchase, but I'd rather just not have them spending my money in the first place. Excuse me. A credit card, on the other hand, is a line of credit where each purchase that you make is with the bank's money, and then you have to pay them back on a monthly basis. They'll give you a statement that mentions the minimum amount due, and the minimum amount due is designed to keep you on the hook for a really long time and paying those high interest rates, because you're much more valuable to the bank if you're continually carrying a balance that is earning interest for them each period. So the people who use credit cards wisely are the ones who pay the balance in full every month, and then you don't have to pay any interest. Like if you make a purchase today and then you pay it off each month in full, then there's no interest due on a credit card. They call that float, where you get to use the money for a short period of time for free as long as you pay every month in full. We discussed what a mortgage loan is, and a home equity loan is a little bit similar to a mortgage loan, except for that it's not for the original purchase of the property, but once you either own a home or if you own some of the house. Let's say that your house is worth $100,000 and you still owe $40,000 to the bank. So the difference between those two, the $60,000 difference, is what's called your equity. That's the fraction of the home's value that you don't owe to someone else. And you can take a loan against that equity. And so a home equity loan is where a borrower is going to use the value of their home as security. And so the interest rate for a home equity loan is a lot lower than it would be for a credit card. So sometimes people use home equity loans to buy a car. Sometimes they're used for home improvements, but they don't necessarily have to be. You could take out a home equity loan and go to Las Vegas with that money if you wanted. But the issue is that the ownership of your house is secured as a pledge against repayment of that loan. Any questions about some of this terminology on different account types? In a couple of weeks, we'll also talk about the difference between stocks, bonds, equity instruments and debt instruments when we discuss how large-scale projects are financed. This is more on the consumer side of things, although businesses do often also have these same account types. Okay. Through the semester, I'm going to show you pictures that are really important. And the goal is that when you see this picture, you'll be able to retell a story about it. This is the third semester in a row I'm teaching this particular class. And throughout the semester, I'm going to try and give you as many hints as possible when there's some idea that the previous 2 semesters the students struggled with. This isn't a game. I want you to learn as much as possible, and I'm not intentionally trying to trick anyone, but just it seems like consistently there are some topics that students find a little bit confusing. And so I'll try and point those out whenever I can to give you the warning that maybe you should focus a little bit more on the textbook and really understand it because it's important. So this is one of them. What I'll sometimes do on quizzes or exams, I'll say, here is an image that kind of illustrates a trend. Tell me, what is the trend? And what's the significance of it? And so what this is showing is that when you borrow money, the cumulative amount that's been borrowed here on the horizontal axis has an effect on the interest rate that is charged by whoever's making the loan. And so look at the trend and see what's the rate. If some hypothetical company is borrowing $1 million, it looks like they have to pay 10% interest for that first $1 million that they borrow. That same company borrows $2 million, the interest rate that they pay is virtually unaffected. But for the third $1 million, you can see now this curve is starting to go up. And each successive $1 million, the annual interest rate is increasing. So can you think why that might be the case? Why is it that a bank would demand a higher rate of return from a company as the amount that they've borrowed goes up?
There's a greater risk in giving them.
Risk. I'm really glad she used that word, risk. There's a greater risk. And so why is there a greater risk?
Because if they don't pay it back, it's a much bigger loss.
Okay, it's a bigger loss. Also, think about any particular company. A company has a certain number of clients. It has a certain amount of revenue it did last year. It has projects in the future. It maybe has projections on how much revenue they have coming in this year. So what this curve is showing is that the bank, before they make a loan, they're going to want to see the books of a company. They're going to want to see how much revenue did you have, what were your profits last year. And what that curve starts to tell you is the bank is getting nervous about risk because they sense there is some increased chance you may not be able to repay. And so what this curve looks like to me is the bank isn't worried about loaning $3 million. I mean, they want to make profit, of course, but the risk isn't really increasing from the perspective of the bank until they get into the $4, $5, $6 million range. And then they think maybe there's a greater risk that something could go wrong. Like if one of those projects falls through, they may not be able to make the repayments on the loans and so on. Okay, so we're going to come back to this figure on Friday and expand on it a little bit more. On the back side of the in-class exercise I've given you is 2 more questions, and these are calculation questions, just to kind of reinforce what we did in class last time. But this time, I've introduced a new equation, and I don't want to tell you too much about this equation. We'll get into it in the future, but I'd like you to see if you can kind of pick apart how to use this equation and pick apart the word statements here. And in question 2, we're calculating some future amount that is owed. And question 3, you're solving for an interest rate. Of course, feel free to discuss amongst yourselves. I encourage that during the in-class exercises. All right, let's take a quick look at the solution, make sure we're all on the same page with problem 2. So I think as I was circulating around, it looked like most people correctly identified that P is 85,000. So P here meant present. F means future. Okay, so P is 85,000. The interest rate isn't going to work unless you convert that to a decimal. So if you put I is 9.5 and then put it directly into that formula, it's going to be looking kind of crazy. The future amount would be really off the charts. So you have to convert that annual interest rate, because percent means out of 100. So that's what that percentage sign means, is it means divide by 100. Okay, the future is what we're trying to find over the course of 3 years. So 111,599. Who else got that? Okay, good. Now, this formula, F equals P times 1 plus I to the n, that accounts for something called compounding. Maybe some of you are already familiar with compounding. We're going to discuss compounding in more detail in the future, but the first glance of that concept is that when there's compounding, you have to pay interest on the interest. And so the way to look at it is that after 1 year, whoever, I guess that's us that's borrowing the money, at the end of 1 year, we owe $85,000 plus 9.5% of $85,000. That's how much we owe at the end of 1 year. But the end of 2 years, we owe interest on that total amount from the previous. And so each year that you keep going, you have to pay the 9.5% on the original balance, and also all of the interest that has accumulated up until then. So we'll go through these compound interest calculations in the future, but I wanted to acknowledge that that's what this formula is meant to do. It's meant to account for compounding interest over time. Any questions about this first one? All right. On question 2, I use the solver on my calculator, but you can also solve it by just algebraically 4250 divided by 3500, and then you take that to the 1/4 power, which leaves you on the right side 1 plus I, and so then I would be 4250 divided by 3500 to the 1/4 power minus 1. And so either way you do it, whether it's the solver in your calculator or algebraically, or you could even do it just by iteration, trial and error, until you happen to randomly guess the correct I value that makes this equation work out. That's essentially what your calculator's doing, is a numerical solution. 4.97%. That's the interest rate for your uncle. Any questions about that one? Okay. Well, let's take one last look at these announcements before I turn you loose. Remember that the homework number 1, that's due no later than tomorrow at noon. It will vanish off MU Online, and you'll lose your opportunity to submit it at 12 o'clock. And then homework number 2, the PDF is posted. You can get started on that, and it's due by Wednesday at 12 p.m. All right, have a great day, and I'll see you on Friday. No, you can keep these papers today.